Okay, hello Algebra 2 students. Once again, this is the second video for the week of 427. There are two videos this week. The first video, you should have just already watched that. It was solving exponential equations. Now we're going to be solving using radicals. But please remember, you will not see homework problems after the first video. You'll only see it at the end of the last one, which is this video, the second video. So at the end of this video, I'll flip it over and show you guys homework questions. All right, just real quick, what we saw on the last video was, hey, if we have an x squared, how do we solve for x? Well, simple. We square root the x. That cancels it out. You're just left with x. Well, what if we have an x to the power of 3? Well, we cube root it. Cancel that out. We're left with x. X to the power of 4 needs to be fourth rooted to be canceled out, just to be left with x, and so on and so on and so on. Okay, great. That's just prerequisite knowledge you need to know. Another thing you need to know for this video really is this: is there a difference between these two answers? Are these two answers different? Okay. Well, let's think about this. What are you squaring in this problem? You're not squaring a -5 because PEMDAS tells you have to do exponents first before you multiply this negative to this 5. So in this case, you're actually doing 5 squared first. 5 squared would be 25. And then you apply the negative. So that answer is -25. Let's look at the second problem. This one, I'm not just squaring the 5. Since I have parentheses here, that means this entire -5 needs to be squared. So that means what's -5 times itself? -5 times -5, and that's going to be positive. So please be careful. If you want to square this entire thing, the entire -5, that's how you do it. Because if you don't put in parentheses, you just put that. I mean, in certain situations you're going to have this, but I'm just saying if you're trying to square this whole thing and you just put a square there, that only means 5 squared and then apply the negative. Okay, you see that a lot when you're doing like quadratic formula and solving and all that, solving quadratics and all that. Okay, so moving on here, I'm going to erase this and I'm actually going to start off the problem now. Let's do it. I'm going to start with two easy ones, and then I'm going to get a little bit harder. Okay, 3x to the power of half plus 5 equals -1. All right, I'm going to go a little bit faster this one because last video I did a lot of this. Okay, so I'm going to go -5 here, -5, new line. Notice I crossed that. Left to right, write it down, 3x to the power of half. This is gone, so it just equals -6. Divide by 3. What I do to one side, I do to the other. Divide by 3. I'm left with x to the power of half equals, that's going to be negative divided by positive is negative. That's 2. Here's the problem. Here where it lies. X to the power of half. It seems confusing to me. I'm not really sure what that looks like. But if you remember from a couple of videos past, we said you have something to the power of a fraction. You could think of the top number, the numerator, as the power, and the bottom, the denominator, as the root. So we're going to rewrite this as x to the power of 1, but then to the square root. Now, when it's square root, you don't actually put that 2. It's an invisible 2. Keep that in mind. To the square root. And really, in this case, we don't need the power of 1 either, because anything to the power of 1 is the same thing. So we're just going to say, that's just going to essentially just be square root of x equals -2. Okay? Now we need to solve for x. That square root's got to be gone. How do we get rid of square roots? Simple. We're going to do the inverse, the opposite, if you want to think of it that way. The opposite of square rooting something is to square it. And that cancels out the square and the square root. What I do to one side, I must square the other side. Notice I put it in parentheses because I can't just put a square there. I'm doing the whole thing. What I do to one side, I do to the other side. So you must do to the whole thing. And that's what I was just talking about just a second ago, okay? So what's that? Square root and square cancel. So I'm just going to x equals -2 squared. That means -2 times -2, which is positive 4. Okay. Let's do another one like this. Okay, let's do another one. I know that seemed like a bit much. Another one. Okay. Let's try this one now. Okay, I don't mean to scare you, but these are the easier two. Okay, the last two are a little bit harder. 5x to the power of 1/3 minus 2 equals 8. Again, I'm going to zip through this as fast as I can here, okay? Plus 2 plus 2. I got 5x to the power of 1/3. That's gone, so it equals to 10. Divide by 5. Boom, cancel out. What I do to one side, I do to the other. Boom. X to the power of 1/3 equals 2. So 10 divided by 5 is 2. Now, let's rewrite this. Remember, power of 1 and the root of 3. So it's going to be x to the power of 1, which I don't really need to write, okay? Because x to the power of 1 is just x, doesn't change anything. But the root is not going to be a square root this time. It's going to be a cube root or a third root. Equals 2. All right, now, last step here. Let's get rid of this cube root. Again, inverse of a cube root is to cube it. What I do to one side, I do to the other. So notice I put it in parentheses. What's going to happen here? Can't open my pen apparently. Okay, the cube and the cube root are going to cancel. Okay, you're going to be left with just x equals 2 cubed, which is 8. Good job. All right. I moved through that a little bit quickly just because these last two are a little time consuming, okay? So let's erase that. And I suggest you pause. You can take a screenshot or just copy it down, whatever, because I'm going to be going a little bit faster. All right, now let's change it up a bit. Let's give you something like this. Square root of x plus 6 equals x plus 4. Okay. So this looks a little different because I have x here and I have x here. But we're solving with radicals and exponents here. So what I want to concentrate on first is this radical. I want to get rid of that. I can't solve this while I still have that radical there. I want to get rid of that square root. How do you get rid of a square root? Well, just like our last problem. Square root, you square it. Cube root, you cube it. Fourth root, power of 4, and so on and so on and so on. So if this is the square root, I'm going to square it. But remember, it's the square root of x plus 6. The entire thing is a square root. So I'm going to square the entire thing. What I do to one side, I do to the other side. Don't just put that square on the x or the 4. No, the whole thing. X plus 4. The whole thing has to be squared. All right, let's see what happens here. Square and square root get canceled, so we're just left with x plus 6 equals. Now, x plus 4 squared, here's the juicy part, guys. That does not mean, oh, x squared and 4 squared. No. That, you don't do it individually. This whole thing has to be squared. So that means squaring something means multiplying it by itself. So I have to get x plus 4 and multiply the whole thing by itself. That means x plus 4 times x plus 4. Right? Very important concept here. Let's rewrite from left to right. Ready? X plus 6, I haven't touched that yet, equals. Now this I have to actually multiply out. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Now, if you guys notice, there actually are two like terms here, 4x and 4x. I should be adding those right now, okay? So that's what I'm actually going to do. So don't blink. Okay? So x squared plus 4x plus 4x. So I'm just going to write that down as x squared plus 8x. Okay? Plus 14. So now what do we do? Because I'm thoroughly confused now because I'm looking at this and I'm saying, great, I did all that, but I have x's here and I have x's here. If you look closely though, you realize this is a trinomial. This is a quadratic right here. We can solve quadratics. Diamond method, X method, quadratic formula, complete the square, whatever. You've learned all those methods in the past before. Give you a little hint. We're going to give you these that are factorable. So you're going to be using X method or diamond method for the most part. So, and it's going to work out cleanly. We're not that mean. We're not going to give you problems that are that complex. You're going to do all this work and then you have to like use complete quadratic formula or something. No, we're not going to ask for that. It's going to be factorable. The problem is this though. Whenever you factor something, diamond method something, like if I were trying to do that, you'd have to equal to 0. It's always equal to 0. Quadratic formula will set it equal to 0 and then solve it. Set it equal to 0. This is not equal to 0. It's equal to x plus 6. So simple. We're just going to move this x and the 6 over there, one by one. Ready? We're going to move the 6 by doing minus 6. And minus 6 will go here. That's the like term. We're going to move the x by doing minus x. And minus x is going to go here because it's like terms with the 8x. You guys see what I did here? This is all gone. We're just left with 0 equals x squared. 8x minus 1x is 7x. 16 minus 6 is 10. All right, so we got that. Cool, beautiful, nicely done. What now? Well, you've done about 75 to 80% of the work. You've done the hard part. Now it's just an algebra 1 problem. You have a quadratic here, you need to solve it. Well, we're going to see if it factors. Let's use x method. And it will factor, don't worry. Again, like I said, we're not going to be that mean. The garbage truck is passing by. It's going to be noisy. I apologize. I'll be a little bit louder. A times C. A is 1, C is 10. That's going to be 10. B is 7. So, a little puzzle here. What multiplies to give you 10, but adds up to give you 7? It's going to be 5 and 2. Or you can say 2 and 5. 0 equals, the way we write this out is x plus 5. And this is going to factor into x plus 2. Whew! Almost done. Not quite. Remember zero product property here? We actually have to solve to get the zero product property. And what that means is we're going to solve. We're going to do a little mental math here, okay, guys? I'm going to have you guys, I'm going to cover this up and solve that part. X plus 5 equals 0. Okay, my arms hurt right now, but anyways, you're going to do it. You can do x plus 5 equals 0, and you're going to minus 5, and you can get x equals negative 5. X equals negative 5. We're going to do the same thing for this guy. We're going to cover this guy out. Zero product property. You're going to solve this. X plus 2 equals 0. And you're going to get minus 2 here, minus 2 there. And you're going to end up getting, x equals negative 2. And that one is done. That's a long problem. We still have one more. Okay, so sorry this is a slightly longer video. I want to do one just like this. All right? Picture that. Screenshot it, erase, and write it down, whatever you want to do. Okay, curse it out if you want to, whatever you want to do. I know it's not a fun problem, okay? We're going to do one just like it. And this is the last one. I'll do this one, then I'll flip it over in just a second so you can see the homework problems. All right. Oh, okay. Those are back-breaking problems. All right. Square root of x plus 3. And I'm going to go a little faster on this one, okay, guys? Equals x plus 3. Square root. Let's get rid of it. We are going to square it to get rid of the square root. What I do to one side, I do to the other. Next, when I square a square root, cancels out, so we're just left with x plus 3. Now I'm going to do x plus 3 squared, which means x plus 3 times itself. X plus 3 equals, now I have to multiply x plus 3 times x plus 3, which is boom, 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 and boom. That's going to give you x squared. Plus 3x plus 3x plus 9. Well, I'm not going to stop there because I do know that 3x plus 3x are like terms. That's going to give us 6x. Next, I want to solve this. It's not set equal to 0, though. This trinomial is not set equal to 0. So I'm going to move these guys. Minus 3, and that goes with its like term. Minus x, who's a like term for x. That's going to be this guy, so minus x there. We're left with 0 equals x squared. Oops, sorry. The crusty one. That's going to be 6x minus x is 5x. 9 minus 3 is 6. Okay. Now, some of you could probably factor this in your head and figure this out, but I'm just going to do x method just to do it step by step. A times c goes up here. Diamond method. Some of you call it diamond method. That's fine. A times c is 6. B is 5. What two numbers multiply to 6 add up to 5? That is going to be 2 and 3. So we're going to rewrite this as, watch this, x plus 2. We write this as x plus 3. We're almost done. Now, zero product property. I'm going to cover this one up and solve that. That's going to be x equals, so we do minus 2 minus 2. 0 minus 2 is negative 2. That's x equals negative 2. We're going to do the same here. I'm going to cover this up and solve that up. Minus 3 minus 3. We're going to get x equals negative 3. So x equals negative 2, x equals negative 3. We have our two solutions here. Whew, I know that was a doozy, guys. All right, flipping it over right now. The homework problems are in the back. Now, a sheet of paper. Oh my goodness. I copied it on the wrong side. Yes, I did. It's okay. Yeah, I wrote those problems on the wrong side. It's okay. All right. So here are the homework problems for the week of 427 for Algebra 2. Problem number 1, 2, 3, 4, 5. 1 and 2 were from the first video. 3, 4, and 5 were from this video. All right. Good luck, guys.